the calcifying reason your blood carries the exact mineral Mono Lake uses to build its towers from nothing, and in 1941, Los Angeles started drinking that mineral dry. Right now, something is growing in the middle of a California desert lake. Not algae, not coral, stone. Prehistoric limestone spires erupting from the water like teeth. Nobody planted them, nobody built them, and the lake keeps making more. Mono Lake sits at 6,400 feet in the eastern Sierra Nevada, and it has no outlet. No river carries its water away. The only escape is evaporation, which means every mineral that ever washed into this lake has been concentrating for 760,000 years. The water is 3 times saltier than the ocean, and so alkaline it would dissolve a hand in a matter of weeks. But something lives inside it, and something builds inside it. The towers are called tufa. Some stand 30 feet tall. Some are growing right now, underwater, in columns the color of bone. Calcium carbonate locking itself into permanent record. And here is the part nobody wants you to notice. That mineral, calcium carbonate, is the same compound your skeleton is made of. Your bones, your teeth, your joints. The architecture inside your body and the architecture rising from this toxic lake are built from identical material. When freshwater springs push up through the lake bed, they carry calcium. The lake water carries carbonate. The moment they meet, the chemistry reacts. Calcium locks onto carbonate and solidifies. A tower begins, slowly, invisibly from the bottom up. It has been happening for thousands of years underwater. Nobody saw it. The towers grew in the dark in silence, in a lake so hostile that almost nothing else survives in it, except brine shrimp small enough to sit on your fingertip, and a fly that walks on water with a bubble of air trapped against its skin. The spires grew, and the lake kept the secret. Until 1941, when Los Angeles found out the lake existed. Here is what Los Angeles did. It diverted every freshwater stream feeding Mono Lake. Channeled them south through an aqueduct 350 miles to fill swimming pools and water lawns in a city built on desert. The lake started shrinking, and the towers started surfacing. For 40 years, the lake dropped 45 vertical feet. What had been an underwater sculpture garden became exposed shoreline. The towers the lake had been building for millennia stood naked in open air. People called them beautiful. Tourists arrived. Scientists arrived too. And what they found underneath the revelation didn't make sense. The towers weren't dying in the air. Some of them were still growing. This is where the science gets uncomfortable. Tufa is supposed to need water to form. The reaction that builds these towers requires that chemical handshake, calcium from underground springs meeting carbonate from the lake, in solution. When the towers emerged from the water, the reaction should have stopped. The towers should have been fossils. But in specific clusters around the shoreline, new mineral deposits are forming on exposed stone. Thin, chalky crusts layering onto formations that have no business growing in open air. The leading theory involves capillary action, water wicking up through porous tufa from saturated ground below, carrying dissolved minerals with it, continuing the reaction millimeters at a time above the waterline. Slow, quiet, unstoppable. But that theory has a problem. Some of the growth zones aren't near the shoreline. They're on towers standing in the middle of dry flats, 100 feet from water that hasn't touched them since the 1970s. The nearest subsurface moisture is too deep. The capillary math doesn't reach. A second theory involves atmospheric moisture, fog and dew carrying dissolved carbon dioxide that reacts with calcium already locked in the stone, adding layer by layer on dry air alone. But the growth rates don't match the moisture data. There is more growth happening than the moisture models explain. Something else is contributing, and nobody has identified it yet. What this means is that Mono Lake contains an active geological process operating partially outside its known mechanism. The lake became a legal landmark in 1994 when a California court ordered Los Angeles to let the water level recover, protecting the chemistry that drives the whole ecosystem. The lake has risen 15 feet since then. More towers are now submerged again, reforming in the dark. And the ones above the waterline are still doing something scientists can't fully account for. This matters beyond one lake. If calcium carbonate can self-assemble under conditions we don't understand, then every model we have for how stone forms, how mineral deposits accumulate inside cave walls, inside pipes, inside human arteries may be missing a variable. The same mineral building your bones, the same process, the same unexplained acceleration. The lake is 760,000 years old. Human study of it spans 50 years. We may have arrived mid-sentence, watching a geological process we don't have the context to read. There are 17 other salt lakes on Earth with tufa formations, none studied at the depth Mono Lake has been. Which raises the question nobody in the scientific literature has answered directly. If the growth mechanism is partially unknown here, in the most studied alkaline lake on the planet, what is happening in the ones we haven't looked at yet?